Let's look at using the sampling distribution for sample proportions. This model says that my sample success rates should be close to my population success rates. In other words, if I were to flip a coin enough times, I should be able to estimate the true probability of getting heads, say, within a certain level of accuracy. This goes both ways. So I can also use population claimed values. For example, they tell me I should win this scratcher 20% of the time, to determine the likelihood of winning 25% of the time or more out of 160 scratchers. So what this model does is, knowing something about P, it tells me what should happen for my sample P hat. So just a little bit of vocab and things as I'm looking at this. N, lowercase n, is the number of samples. And for this problem, it seems like I'm dealing with 160. My population success rate, they tell me I should win 20% of the time. If I win 20% of the time, Q is my failure rate. They're complements of each other. Winning 20% means you're losing 80%. Now, the question I'm trying to answer is how likely, in other words, what is the probability of a win rate, so a sample win rate, a p hat, of 25% or more. So I have a question about sample proportions, and this will be the model for sample proportions. So I'm going to answer this thing based off of this formula. So I'm going to plug in my numbers in here, and then I'm going to draw my normal curve. I'm going to find my z-scores, and I'm going to look it up. So for P, that's my sample success rate, I'm plugging in 20%. For Q, that's my failure rate, that's 80%. N, that's the number of samples, that's 160. So population success rate, population failure rate, total number of samples. You'll notice I didn't plug anything in for capital N. That's because this stands for the normal distribution. It tells me what the curve's going to look like. I also don't plug in anything in for this p hat. It tells me which types of problems this thing can deal with. So I'm going to use this model whenever I'm dealing with something involving sample percentages. Now, center is 0.2 or 0.20. The standard deviation, if I type this into my calculator, is about 0.0316 or so. When you're writing out the standard deviation, you might want to have a couple more decimals than you're used to, because think about moving the decimal 2 place over to make that a percentage. 3.16 is your standard deviation, 3.16%. So I'm going to draw my model that has a center of 20% and a standard deviation of 3.16 from that. Now, my question is asking me about a success rate of 25%. That sample success rate is about here. It looks like it's 1.5 standard deviations away or so. And I want that much or more. So we're going to find the z-score, and then we're going to look this thing up in a table. To find the z-score, I'm going to take the value that my question is about. I'm going to subtract the center of the model, and I'm going to divide this by the standard deviation of the model. My question was about 25%. The center of my model was 20%. And my standard deviation was 3.16. So when I type this in, looks like I get a z-score of approximately 1.58 or so. I'm going to look this up on a normal table here. You could easily use technology as well, so you could use GeoGebra to find these z-scores, or you can do this inside of a calculator, whatever you're comfortable with. I've got my table up and ready though. So I'm going to look up this 1.5 row meets the 8 column inside of the table. 1.5 meets the 8. It looks like it happens here at a table value of 94.29. So this means I have 94.29% of my area, noticing my table is shaded to the left here, in this white region that I actually don't want as my answer. I've managed to find the area shaded to the left, but I wanted the area shaded to the right. Easy to fix. If I want the area of this much or more, anything shaded to the right will be 1 minus the table value, which gives me 0.0571 or so. In other words, there's a 5.71% chance of winning a game 25% of the time or more out of 160 trials if the true probability of winning is 20%. I can examine sample success rates using this model. P hat is normally distributed with the center of P and a standard deviation of root PQ over N. And as soon as I set up this model, it's just a matter of finding and looking up those z-scores.